Okay, g'day folks, welcome back to Kieran's Trading. So today we're going to be looking at the calculations required for intermediate rigging. Okay, so the first aspect of intermediate rigging we're going to look at is doing multiple crane lifts. Okay, so when we're doing multiple crane lifts we need to allow for extra loading. Right, the load share on the crane is going to change as they're roping up at different intervals. Alright, the load can change. Right, so what we do, if we've got two cranes lifting a load, we allow an extra 20% loading. Alright, so in order to do that, if we've worked it out that crane A is going to be lifting 3 tonne and crane B is going to be lifting 6 tonne, right, then we need to allow 20% on top of that. Right, so in order for crane A to lift 3 tonne, alright, you go 3 times 1.2, right, which is going to equal 3.6 tonne, alright? Right, so crane A, 3 times 1.2, so we're allowing that extra 20%. So crane A must be capable of lifting 3.6 tonne. Alright. Same again with crane B. Alright, so crane B is, because it's taking 6 tonne, 6 times 1.2 is going to equal, what have we got? 7.2 tonne. Alright, so when you're setting it up, don't just look at the weight, you need to allow for an extra 20% on top for a dual crane lift. Alright, now, if we were going to be using 3 cranes, alright, with 3 cranes you have an extra load share of 33%, sorry. Alright, so, if we had a third crane in here, alright, let's say crane C is good for 9 tonne, alright. That means for each crane, all right, we've got A, B, and C. A is 3 tonne, B is 6 tonne, and C is 9 tonne. All right, so you multiply them. So being 3 cranes, it's 33% loading. All right, so to get the 33% loading, we simply multiply it by 1.33, 1.33, and 1.33. All right, so we jump on the trusty calculator, we go 3 times 1.33 equals 3.99 tonne, 99 tonne, all right. 6 times 1.33 equals 7.98. And C at 9 tonne, so 9 times 1.33 equals, obviously pressed the wrong button there, so 9 times 1.33 equals 11.97 tonne. Alright, so if there's only 2 cranes, we allow 20%, right? So that 20%, how do we get that? We just multiply whatever figure we have by 1.22. Alright, now 3 cranes, 1.33, because for 3 cranes we allow 33%. Okay, now if we've got more cranes than that, so if we have 4 or more cranes doing the lift, then we've got to allow 50% loading. Alright, so 50% loading, same process, except instead of 1.33 we use 1.5. Okay, so if we had another one down here at D, and let's say D's got 12 tonne, right, get rid of them, 1.5, 1.5, 1.5, alright, so crane A needs to be good for 4.5 tonne. Crane B needs to be good for 9 tonne. Okay, crane C needs to be good for 13.5 tonne. And crane D needs to be good for 18 tonne. Alright, so just keep in mind 2 cranes, 20%, so multiply by 1.2. 3 cranes, 33%, so multiply your crane by 1.33. 4 or more cranes, then we go to 1.5%. So 4 cranes, 5 cranes, 6 cranes, it's all 50% once you get past that 4. Alright, so that's the first thing we need to do with calculations for intermediate rigging. Alright, now we'll have a slight variation on that. Alright, let me get rid of some of this. Alright, we'll leave that up there. Okay, so what we're going to do, we're going to have 2 cranes lifting a load, right? They're not going to have the same amount, right? Two different capacities cranes, right? So we'll have a load weighing, let's say it's weighing 30 tonne. All right, let's say it's 15 metres long. All right, the capacity of crane A is going to be 24 tonne, and the capacity of crane B will be 16 tonne. So that will be A, that will be B. All right, I'll see if I can find a marker that's going to be a bit clearer. Let's have a crack at this one. All right, so first we want to find out is how much load share we want each of those cranes to carry, right? With the different capacities between the cranes, we want to make sure they're getting equal load share for their capacity. All right, so how we do that? First, we look at the capacities of the 2 cranes, all right, and we're going to add them together. All right, so we've got crane A plus crane B, so 24 plus 16 is going to equal 40 tonne. All right, so the total capacity of the 2 cranes is going to equal 40 tonne. Okay, now that we know the total capacity, all right, we want to find out the percentage of 40 tonne that each one is going to be. So essentially, we've got our total 40 tonne there. To find out what percentage 24 is of 40 tonne, 24 divided by 40 equals, just grab my calculator. All right, so 24 divided by 40 equals 0.6. All right. Now, if you multiply that by 100, you'll then get the percentage of the load. All right. So times 100 equals 60%. All right. So we want crane A to have 60% of that load. All right. Do the same again with crane B. All right. So crane B is 16 divided by 40. Which will equals 0.4 because it's going to add up to 1. All right, multiply that by 100 equals 40%. Okay, now if your 2 figures here don't add up to 100%, you've gone wrong somewhere. All right, because in total we want 100% of that load share. All right, we want crane A to take 60% of it, and we want crane B to take 40%. Okay, so now that we know that, we want to figure out how much weight we want each crane to carry, all right? So, what we'll do, we want crane A to carry 60% of that 30 tonne, all right? So, we go 30 times 0.6 is going to equal 18 tonne, right? So we want crane A to be carrying 18 tonne, all right? Same again with crane B, so the 30 tonne times the 0.4 because we want crane B to be carrying 40% of the load is going to equal 12 tonne. All right, so once again, those 2 figures there, they should equal the weight of your load. Okay. So we want crane A to be carrying crane A to be carrying 18 tonne. We want crane B to be carrying 12 tonne. Okay. Now that we know how much we want each crane to be carrying, right? Then we need to then take into account our extra loading. So being a 2 crane lift, all right, we need to remember we could need to add 20% to that. Okay, so we've got our 18 tonne times 1.2 times 1.2 is going to give us what capacity crane is going to be required. Okay, so let's just do that on the calculator. All right, so we've got 18 times 1.2, 18 times 1.2 equals 21.6 tonne. 21.6 tonne. Right, so in order to lift that load, crane A must be good for at least 21.6. It's good for 24 tonne, so we're pretty happy with that one. Okay, crane B, all right, we know it's got 12 tonne load share, so we want to add our extra loading. So 12 times 1.2 is going to equal 14.4 tonne. Okay, so now that's the value that we want capacity of each crane. All right, so got 24, that's within the 21.6. If this figure was over what we've got there, then we're in a little bit of trouble. All right, then we'll need to get a bigger crane. Okay, so that's the first step. Now, to figure out whereabouts we're going to sling this load so that each crane is going to carry that amount of weight. Okay, so crane A, we want to carry 60% of the load. All right, so how do we figure out where to sling it? The total length of the load is 15 metres, and we want it to have 60% of that 15 metres. Okay, so 0.6 times 15 is going to equal 0.6 times 15 equals, so we want crane A to be carrying 9 metres of that 15 metres. Okay, crane B, right, which is carrying 40%, so 0.4 times 15, well, it must be 6 metres because it needs to add up to 15 in total. Okay, final part of this part of the equation is where are we going to sling the load in order to make sure crane A is carrying 9 and crane B is carrying 6. Okay, so if we look at our load here, we know the middle of the load is going to be at 7.5 metres, all right? We want crane A to be carrying 9 metres, all right? So we want it to be carrying about 9 metres, say about there, 9 metres. All right, so in order for crane A to be carrying that much, we divide that by 2 and we'll sling it right there. So 9 metres divided by 2 is going to equal 4.5 metres. So we want that first crane slung 4.5 metres in from there. Okay, same again on crane B. So crane B is going to be carrying 6 metres. All right, so 6 metres divided by 2 equals 3. All right, so, and crane B, all right, that will be 3 metres from the edge. Okay, so just stepping through it again. First up, find out your load share. Each one is going to be carrying. All right, so add the two capacities together, right, and then divide each crane into that total capacity to give you a percentage of the load. All right. Once you know the percentage of the load, all right, then you can work out how much of the load it's going to be carrying. All right, so find out 60% of the load, so 0.6 times the load. All right, or whatever your question may be. All right. Same again on the next one. The next one's going to 40%, so it's 0.4 times the load. Okay. When you know how much the load each one's carrying, so in this example 18 and 12, we then apply our extra loading for the dual lift. So multiply each by 1.2 to get our 21.6 and we get our 14.4. Okay, now to work out how much of that load each one is carrying, then you look at the length, all right? We want crane A to carry 60% of it, so 0.6 times the length of the load will tell you how much of that load, i.e. 9 metres, all right? Same again on the next one, which is going to be 6 metres. Then divide each of them to find out where your slinging points are on the load. Okay, now we'll go from that and we'll look at some tilt panels. All right, so with our tilt panels, just let me clear this off. Okay, get that. Okay, so we're going to have a tilt panel. Okay. Now, let's say we're going to use a spread bar to lift it. All right, and it's got some lifting points there and there, there and there. All right, it's going to run up through the equalising machine and back down. All right. Now, what we need to do is we need to find out what length flexible steel wire rope is going to be required in order to lift that. Right. If you leave them too short, you won't have enough height and you're not going to clear the top of the panel. So as it tilts up, it's going to start fouling on the sheets. Okay, so quite a simple one. All right, so you measure the distance between these two. Okay, so if the distance between those two was to be 4 metres, all right, then to find out the minimum length sling required, all you do is multiply that by 2. All right, so 4 metres times 2, okay, equals a minimum length of 8 metres. Right, quite a simple one. Okay, what should we look at now? Okay, so nice and simple, that one, we won't go too much into that. So what we've got to look at, so if your distance there, so let's say that's D, so it's D times 2, so 4 metres times 2 is going to give you your answer. All right, now let's look at some of the what's required in terms of doing demolition work. Okay, so let me just get rid of this again. Okay, let's have a look. Here's one I've already got written down. So, you've been asked to fell an encased concrete column, right? And the dimension of the column is going to be 400 mil square and 5 metres high. Okay, so our column. So, 400 by 400 and 5 metres. Okay, so we've got our column, right, made out of concrete. Okay, so first thing we need to do is we want to find out the weight of that column. Okay, so we'll go back to what we did in dogging, right? The simple formula of length times width times height to find the volume. Once we find the volume, then we can multiply it by concrete, as concrete is 2,400 kilos per cubic metre. Okay, so 0.4 times 0.4 times 5. So remember, we are working out cubic metres, so that 400 millimetres we need to convert to metres, all right? So that equates to 0.4. Okay, so 0.4 by 0.4 by 5, 0.4 times 0.4 times 5 equals 0.8. Right, so the volume is 0.8 metres cubed. All right, to find the weight, it's made out of concrete, so 0.8 times 2,400 for concrete. Equals 1,920 kilos. Okay, so once we know how heavy it is, all right, then we can start looking at what equipment is going to be required in order to pull that over. Okay, so whenever we're doing demolition, all right, especially in situ components, etc., all right, we need to allow an extra 50% loading. Okay, so to allow 50% loading, right, so to work out what capacity winch we need to pull that over, right, we've got our 1920 multiplied by 1.5 in order to give us that extra 50% loading. Okay, so times 1.5 equals 2,880 kilos. Okay, so minimum winch capacity in order to pull that over, we want 2,880, and that's allowing an extra 50% for that demolition work. Okay, now, next thing we want to find out is how far away do we need to set that winch up from that job. Okay, so when you're working that out, all right, you go 1.5 times, so 1.5 times the height of the building, all right? Gives you that little bit of safety factor involved in there. All right, so if it's 5 metres high, all right, times 1.5, it means the minimum distance is going to equal 7.5 metres. Okay, so 1.5 times the height, all right, allows it to fall over without landing on top of the winch. Okay, so 5 metres times 1.5 equals 7.5 metres. All right, now, the one last thing we need to try and figure out, right, and that is how close somebody can stand to the side of the winch rope. So we've got our winch, oh, where are you going to see? Over here, okay, and that winch rope is 7.5 metres away. All right, now, how close can you stand to the side of the winch rope? So old mate can't be any closer than 75% of the length of that rope. Okay, so 7.5 metres times 0.75, all right, is going to give us how close we are allowed within that rope. So 7.5 times 0.75 equals 5.625 metres. Okay, so that is the closest distance anyone is allowed to be within the side of that rope. Okay, now remember when you're doing demolition, right, always have the area barricaded out, and only people allowed inside the barricaded area are those involved in the task themselves. All right, can be highly dangerous when you're pulling things over. Right, so make sure you set an exclusion zone and make sure you keep everyone outside of that exclusion zone. Okay, well, thanks for listening. All right, don't forget to like and subscribe. And if you want to stay updated, okay, I will be putting some more videos up very shortly on some calculations for doing C6, C1 and CO. And I'm also going to be taking a look at doing some sling inspections, as most assessments do require some inspection of all the lifting gear that's being used. All right, so stay tuned, and they should be coming up very soon. Okay, thanks for listening. Bye.